We will start with one of the chapter from organic chemistry, alcohol, phenols and ethers. So first of all we will see what are alcohols, phenols and ethers, and then we will continue. So what are alcohols? Alcohols have general formula ROH. Alcohols have general formula ROH, where R is alkyl group. How alkyl group is obtained? It is obtained by removing one hydrogen atom from alkane. So if alkane is CH4, alkyl group we can have CH3, methane to methyl, isn't it? That hydrogen atom which we are removing, okay, if it is substituted by OH group, we will have alcohol. So from methane we will have methyl alcohol. Similarly, if alkane is C2H6, we can have C2H5OH, ethyl alcohol. So what are alcohols in general? Alcohols are hydroxy derivatives of alkanes. Alcohols are hydroxy derivatives of alkanes. Basically they are alkanes. They are obtained by removing one or more hydrogen atoms. Not only one, it can be more also. So one or more hydrogen atoms from alkanes, they are substituted by hydroxyl groups. Those are alcohols. Phenols. Phenols are again hydroxyl derivatives. Phenols are again hydroxy or hydroxyl derivatives of benzene. So they are obtained by removing one or more hydrogen atoms from benzene ring by OH group. They are obtained by removing one or more hydrogen atoms from benzene ring by OH group. Ethers. Ethers are, they have general formula ROR or ROR dash, where R are alkyl groups. Okay. Basically they are alkanes again. Basically they are alkanes, and from alkanes one hydrogen atom is removed and that is substituted by, you will see, alkoxy group. It is substituted by alkoxy group, that is OR group. So we can have CH3O CH3, another alkyl group. We can have C2H5O CH3. We can have ARO C2H5 CH3. So in general, these are alkoxy derivatives of alkanes, basically alkanes, and one of the hydrogen atom from alkanes is substituted by alkoxy group, that is OR group. Okay, so alcohols, phenols, ethers. Okay, now we will go to classification of alcohol, phenols and ethers. First of all, we are going to see classification of alcohols and phenols, and then we will go for ethers. So classification of alcohols and phenols. Both of them contain OH group. Both of them contain hydroxyl group. So based on number of hydroxyl groups, based on number of OH groups, alcohols and phenols, they are classified into monohydric alcohols or monohydric phenols. And we can have polyhydric. Under that we can have dihydric alcohols or dihydric phenols, and we can also have trihydric alcohols or trihydric phenols. So monohydric alcohols. Just now we have seen examples. CH3OH having only one OH group, C2H5OH, isn't it, alcohols. Phenols, only one hydrogen atom is substituted by OH group, that becomes monohydric phenol. Okay, we can have dihydric alcohols. So if you have ethane as alkane, and if you are going to remove one hydrogen atom from both the carbon atoms, and if you are going to replace them by OH groups, what you will get? See, we are going to remove hydrogen atom from this carbon atom and this carbon atom. So CH2, CH2. And you are going to replace them by OH groups, that is dihydric alcohol, because it contains two hydroxyl groups. Okay, we can have dihydroxyphenol also. Similarly, two hydrogen atoms of benzene ring, they are substituted by two OH groups, dihydric phenol. We can have trihydric alcohols or trihydric phenols. So trihydric alcohols, if you have propane, in which three carbon atoms are there, and if you are going to remove one hydrogen atom from each carbon atom, and you are going to substitute them by 3 OH groups. See what we will get. CH3 will become CH2, isn't it? CH3 will become CH2, CH, CH2, OH, OH, OH. Trihydroxy alcohol, glycerol, and we can have trihydroxy phenol also. So we can replace 3 hydrogen atoms, any 3 hydrogen atoms from benzene by OH group, that becomes trihydroxy phenol. So based on number of OH groups, you can have monohydric alcohols, monohydric phenols, dihydric alcohols, dihydric phenols, and we can have trihydric alcohols, trihydric phenols. Okay. Now we are going to see further classification of monohydric alcohols. What we are going to see? We are going to see classification for monohydric alcohols. They contain only one OH group, isn't it? So the classification is based on the hybridization of carbon atom to which that OH group is attached. See, we have only one OH group, isn't it? If the OH carrying carbon atom is sp3 hybridized, okay, that is one type. That means it is bonded singly to other atoms, isn't it? And OH carrying carbon atom can be sp2 hybridized, means it is doubly bonded to other atoms, other carbon atom, isn't it? So this is the basic classification. Now these are further classified. Into 3 types. See, this OH carrying carbon atom is sp3 hybridized, and at the same time it is primary in nature. That carbon atom is primary in nature means what? Is sp3 hybridized. Primary in nature means it is bonded to only one other carbon atom. It is bonded to only one other carbon atom and remaining two are hydrogen atoms, isn't it? So we can have any alkyl group here like CH3, CH5 or any, isn't it? OH carrying carbon atom is sp3 hybridized and secondary in nature. It is bonded to 2 other carbon atoms and 1 hydrogen, isn't it? And OH carrying carbon atom is tertiary in nature, that is, it is bonded to 3 carbon atoms, no hydrogen atom. These are further classified. Into 2 types. See, OH carrying carbon atom is sp3 hybridized. It is primary in nature, that is, it is bonded to only one other carbon atom, and that carbon atom is the part of allylic system. That is, that carbon atom which is primary in nature, okay, it is sp2 hybridized. It is doubly bonded to other carbon atom. That becomes allylic alcohol. What it is? Allylic alcohols. Now we can have again OH carrying carbon atom, primary in nature, and it is attached to only one other carbon atom which is a part of aromatic system. That becomes benzylic alcohols. See, OH carrying carbon atom is sp3 hybridized. It is primary in nature, means it is bonded to only one other carbon atom, isn't it? And that carbon atom is a part of allylic system, allylic alcohols. Okay, the only carbon atom which is present, that can be the part of aromatic ring, benzylic alcohols. Similarly, we can classify these also secondary and tertiary also. So, see how the secondary are classified. OH carrying carbon atom is sp3 hybridized, singly bonded, secondary in nature, bonded to 2 other carbon atoms, and one of the carbon atom is a part of allylic system. It can be CH3 or any group, alkyl group. That is allylic alcohols. We can have again OH carrying carbon atom, sp3 hybridized secondary in nature. Okay, and one of the carbon atom is a part of aromatic ring that becomes benzylic alcohols, like this, allylic benzylic. And similarly, tertiary also they can be classified into two types. OH carrying carbon atom and one carbon atom is a part of allylic system, allylic alcohols, allylic tertiary. And we can have OH carrying carbon atom, tertiary, and one of the carbon atom is a part of benzene ring, aromatic ring, that becomes benzylic alcohols. Okay. Now, one more type. OH carrying carbon atom is sp2 hybridized. Okay, it is bonded doubly to other carbon atom. So it becomes CH, it becomes CH2. Isn't it? This forms vinylic alcohols. They form vinylic alcohols. Okay? So this is the classification of alcohols. Monohydroxy alcohols. Okay? See again carefully. Based on type of hybridization of carbon atom, in the beginning sp3 or sp2, then nature of carbon atom, primary, secondary, tertiary. Okay, and allylic, vinylic, benzylic, then allylic, benzylic, and sp2 hybridized this vinyl group, vinylic alcohols. Isn't it? Last year we have seen allylic group and vinylic group, isn't it? And benzylic group also. Now we will continue with classification of ethers. We will continue with classification of ethers. It is simple. Ethers have general formula ROR or ROR dash. So they are classified into two types: symmetrical and unsymmetrical. Symmetrical ethers, unsymmetrical ethers. Symmetrical ethers are simple ethers, and unsymmetrical ethers are mixed ethers. So symmetrical ethers have general formula ROR, and unsymmetrical ethers have general formula ROR dash. Okay. It can be AR also. It can be ROAR also. Isn't it? So examples are CH3O CH3, both our groups are same. C2H5O C2H5. Or we can have AR O AR. Isn't it? Simple and mixed. Both the groups are different. Isn't it? We can have ROAR also. So this is the classification of alcohols, phenols and ethers, and next time in the next video we will continue with the nomenclature of all the three compounds, alcohols, phenols and ethers.